The next type of inference that we can do on two populations is constructing a confidence interval for the difference between two population proportions. Now that's 2 prop z int on the TI-84, and on StatCrunch, of course, you go to the same place we went for the tests. So you go to stat, and then you go to proportion stats. You would pick 2 sample, and you would say with summary. Right? Same thing we did to conduct a hypothesis test. It's the same place in StatCrunch. So that part doesn't change for StatCrunch. All right, now you'll see that there's a formula here. It has a whole bunch of P1 hats and P2 hats, which is, of course, the sample proportions from the 2 separate groups. And then you have Q hats, which are those complements. The point estimate, which is the center of the interval, is this piece over here, P1 hat minus P2 hat. That right there is the point estimate. It's the center of the interval. And then, you have plus or minus your z alpha over 2 times that big thing. But of course, we learned in chapter 9, and that part is still true, that this is the margin of error. So that basic formula we learned in chapter 9 is still definitely true here. You construct a confidence interval for the point estimate plus or minus the margin of error. At least that's true for most basic confidence intervals and true for all the confidence intervals we are going to create. Now, if you look at the requirements listing here, the requirements to construct this interval are the same that we had for conducting a test. You need to have a random sample. They need to be independent, which is 2 groups measured once, 2 separate groups. What we learned on the first page of this section. And then the samples need to be independent of the population, which is what we did in chapter 9 and 10, of course, but you just need to do it twice, once for each group. And then normal, you need to have n times p times q be greater than 10, but again, for each group, you need to do it twice, once for group 1 and once for group 2. Oh, and it should say a little n1 here and a little n2 here. Sorry about that. I'll fix that for future. And that same mistake I just noticed is on the hypothesis test, as well as the confidence interval, which is this piece that we're looking at right here. So you should just put a little 1 here and a little 2 here, right, to make those match. Sorry about that. All right, so let's put this all together in an example. All right, so researchers from the Pew Forum on Religion and Public Life interviewed 2 random samples of people. Both samples had 1,500 people. In 2002, 645 people expressed support for stem cell research. In 2009, 870 expressed support. So we're going to let group 1, right here, be the 2002 group. All right, so 2002 is a year. It's not an n. So when you want P1 hat, you want x1 divided by n1, which would be 645. There's your x1 right there. And then this is n1, because both samples had 1,500 people. So it's going to be 645 divided by 1,500. And then P2 hat, that would be the 2009 group. So it's 870, so there's x2, and then that's also n2. So it's x2 divided by n2, which is 870 divided by 1,500. And just out of curiosity, let's see what those are in decimal form so we have a better sense of it. So if I take 645 and divide it by 1,500, and 870 and divide it by 1,500, so I get 0.58 right here and 0.43 over here. Now we expect a little bit of change because, of course, nothing in life is perfect. Real life is messy. But the question is this so different that we can, well, basically say that attitudes changed about stem cell research from 2002 to 2009? Well, let's start off by finding the 99% confidence interval for that difference, the difference in the proportion of people who supported stem cell research for those 2 years. And you'll notice right here, it says just give the result. I don't want to deal with that formula because it's ugly. I don't want to deal with it. So you're just going to tell me what the result is, and that's it. That's all. So now in the calculator, you go to stat, you go to tests, and you're looking for 2 prop z int, which is actually kind of closer to the bottom. It's letter B right there, 2 prop z int. So I'm going to grab that, and I would just type in these numbers, 645, 1500, 870, 1500. And then I want to make this 99. Now on the calculator, you can either do that as a decimal or as a whole number. It'll take it either way. All right, so we got the calculator answer of, and if you want, you can actually write a note to yourself. You know, you got this from 2 prop z int, which is negative 0.1965, comma, negative 0.1035. Now that's the calculator. Of course, we wrote the instructions on the previous page for StatCrunch, but we can do it again. All right, so I'm going to close that. That's from a previous problem. So stat, I let my mouse kind of hover over stat. I move down to proportion stat. We're doing 2 sample because this is chapter 11, so you pull your mouse down to 2 sample, and then you click with summary. That's the only one we're ever going to use for proportion stats. Not true for t-stats, but for proportion stats, that's true. So our number of successes was 645, 1500, 870, 1500. And then I'm going to click on the confidence interval part, and I'll make it 99 right here. And then if you want to have a confidence interval plot, you can do so. You can actually click on that. And so when I click compute, it's not necessary, it's just kind of for fun. And I can make this window bigger so you can see the answer, because the confidence interval is these 2 numbers over here, right? The negative 0.1965 and the negative 0.1035. Same answers as the calculator gave. But if you click this little arrow over here, it actually drew a graph of the confidence interval as well. So this end over here is the negative 0.1965, and this end over here is the negative 0.1035. Fascinating, huh? All right. Now, the point estimate. Well, if you were paying close attention, you'd realize that I was just showing it to you. If you let your mouse kind of hover over the line, it kind of brings up this little window where it tells you N1, 1500, N2, 1500, and then see that difference in proportion of successes? See that? Ah, that is your point estimate. It's the center of your interval. It's P1 minus P2, right? So your point estimate for the difference is, well, it says it right on the formula. Here, I'll bring it actually from here. The point estimate is P1 hat minus P2 hat. Simple as that. So that point estimate would be P1 hat minus P2 hat. P1 hat was 0.43. And then I would subtract away P2 hat, which is 0.58. And 0.43 minus 0.58 is indeed negative 0.15. Now, just a little reminder, you can also find it from the interval itself. There's a formula that we learned back a while ago, which is to take the point estimate is the lower plus the upper divided by 2. It's in the last page of section 9.1. The particular semester that I'm making these videos, it's on page 208, but that will change from semester to semester. But you want to look in section 9.1. And right here, we're looking at the point estimate. It's the lower plus the upper divided by 2 because it's, of course, the center of that interval, which we saw in that picture. So we don't have to do this 2 ways, but it's just kind of fun to do it both ways just to prove we know how. So we take negative 0.1965, we add to it negative 0.1035, put parentheses around it, and divide by 2. And if you want, you can make a little note to yourself. 1, that's a formula we've learned, and 2, it came from page, well, whatever page it comes from your semester. For me right now, it's page 208. It's in section 9.1. We've used that several times in chapter 9. All right, so the lower plus the upper divided by 2, and of course I can do that with a calculator. So I can press clear and say, take negative 0.1965, and make sure you're adding the negative signs. Those are those little ones at the bottom, plus negative 0.1035, close parentheses divided by 2. If you're in Desmos, it's actually a little bit easier because Desmos makes it look like a fraction. So if I type the fraction bar to begin with, and then I just type negative 0.1965, and then if you actually just type subtraction signs, it knows that you want a negative. Desmos is very smart like that. So there you have it. Right? All right, so we get one way or another, we're going to get that it's negative 0.15. You do not have to do it two different ways, but for your notes, you want to do it two different ways to kind of remind yourself. If you have the information, you can just do the subtraction, but if you have the interval and you don't have this information, then you could still find that point estimate. Because of course, what you're finding, and actually I'm going to draw the interval right here. So here's negative 0.1965 over here. And over here is negative 0.1035. So what we just found is the center of that interval. It's P1 hat minus P2 hat, which is negative 0.15. That's the point estimate. It's the single value that establishes the center of your confidence interval. And your confidence interval goes from one end all the way to the other end. All right, now what about the error? Well, the error, remember, is this distance here, from that end to the center, or from that end to the center. And again, on page 208 in the particular semester I'm making this, we learned that error has a formula. It's the upper minus the lower, put it in parentheses, divide by 2. That is a formula that we learned and we have used, and we're still going to use it. So you can kind of make a note to yourself. It comes from page 208. It would definitely be something I would include on your exam note packet. But for your purposes, again, the page number will change from semester to semester, but the section number will not. It is in section 9.1. And then we used it again in 9.2 and again in 9.4, and now we're using it again in 11.1. Okay, so for us, we will take the upper, which was the higher number, which is negative 0.1035, and we subtract the lower number. Subtract negative 0.1965. And of course, if you're thinking subtracting a negative, that means you add. Yes, indeed, you do. And of course, we can use StatCrunch, or not StatCrunch, we could use Desmos, or we could use the calculator. I'll use Desmos first, just for some variety. So I'm going to type the division sign first, and it makes the fraction kind of appear. And so then I want to minus a negative 0.1965. And I'm going to divide it by 2. And there you have it. And if you want to see it in the calculator, it's the same thing. Parentheses. And now, calculator, you have to be careful. You have to use the negative sign, not the subtraction sign. Desmos doesn't care. So if I do 1035 minus a negative, so that's plus 0.1965, close parentheses, divide by 2. There you have it, 0.0465. It's half the width of the interval. That's your margin of error. The margin of error, remember, is the part that you're adding and subtracting away from your point estimate to make the interval. Right? So if I take negative 0.15 and I add 0.0465, I end up here. If I subtract 0.0465, I end up over here at negative 0.1965. All right, now how to interpret it. Well, we saw that as well. There's a script that we follow, more or less, and it was in section 9.1 that it was presented. It would be earlier in the section from the last page. So it's, let's see here. Here it is. So it's on this page that has all of these multiple intervals, and we're really using the informal interpretation. The formal interpretation is actually this piece where you build lots and lots of intervals. But the informal interpretation is the one we use more often, which is just saying we are 95% confident, yada, yada. So for us, we're 99% confident because we did a 99% confidence interval. So we are 99% confident that the true, now what were we talking about here? You have to put in the context. And what we're talking about is the difference in support for stem cell research from 2002 to 2009. We're talking in the difference in the proportion of support. So the true difference in the support for stem cell research from 2002 to 2009 was between, and then I'm going to turn these into percents, negative 19.65% and negative 10.35%. Now, technically, you don't really have to put the negatives in here because they were both negative, and the negative just happened because the support grew, right? So if 2002 is your first year, then you're making it so that it grows. But nevertheless, if you'd like to have it, if you want to drop them and just make it positive, that's fine. I would reverse them then and make it go 10.35 to 19.65. In other words, if I had made group 1 2009, they would be all the same numbers, but they'd be positive. They'd be flipped, positive 0.1035 and positive 0.1965. So the group, which one's group 1, affects whether these numbers are positive or negative. That's all. But you can just leave it at negative. It's fine. All right, now does this confidence interval suggest that there is a change in views from 2002 to 2009? Oh, yes, it does. A very big change, and this is an important point. Okay, so in Chapter 11, all through Chapter 11, let's look at the null hypothesis for just a second. Throughout Chapter 11, the null hypothesis is always going to be that group 1 equals group 2, whether we're talking about proportion or if we're talking about means, right? We're always going to say, hey, group 1 is equal to group 2. Okay, so if that's our supposition, right? The null hypothesis is always that P1 is equal to P2, that group 1 is equal to group 2. And that would mean that the null hypothesis is always that group 1 minus group 2, if I subtracted P2 from both sides, would be 0. And that's the key point. If there's no difference, then 0 would be in the interval, right? If there's no change, no difference, no change, then 0 would be there. That's our null hypothesis. The whole chapter is that the two groups are the same, that they're no different. Well, look at this interval. This is negative to negative. 0 is over here somewhere. In fact, I'm going to have to draw it right there. There's 0. 0 is not in the interval. 0 is outside of this interval, right? If they were no different, 0 would be in the interval because 0 is that there's no change. But 0 is not in our interval. Therefore, there is a change. There is a difference. Here's the interval from here to here. 0 is outside of it. Which leads us to a couple things. To show a significant difference, the interval must not contain. So to show a significant difference, the interval must not contain 0. Our interval does contain 0, right? So, our interval does not. So because 0 is not contained within our interval, this implies there is a significant difference I'll just say in stem cell support. Stem cell research support. And it is, you are too young, most of you that are watching this to know, but it was a big election fight. In 2000, actually, President George W. Bush had a big campaign saying that he would get rid of support for stem cell research because it was very controversial because at that time it could only be done with embryonic stem cells. So feel free to research that. But of course, that has changed over time because there's new methods of getting stem cells, and because stem cell research and stem cell therapy is so promising. So maybe we'll be able to get a lot of great cures out of it. And so the support for it has grown. It is not nearly as controversial now as it once was. And that's what this is showing. From 2002 to 2009, even that 7-year difference was showing a significant difference in stem cell research support because 0 is not contained between those two numbers. And that's how we show there's a significant difference. Make sure you highlight that and put it on your note sheet. To show a significant difference, actually through all of chapter 11, your interval must not contain 0. If it does not contain 0, there is a significant difference. If the interval contains 0, then that implies there is not significant difference. Right? So those two things go hand in hand. Make sure you have them highlighted and put on your note sheet for the exam.